Hello everyone and welcome to this week's OpenGL 3D game tutorial, and this week I'm going to be showing you how you can implement cel shading. So it's going to be a bit of a quick one this week because I had originally wanted to cover normal mapping today, and I'd been preparing a tutorial for that over the last couple of weeks and getting it all set up, as you can see here. But unfortunately, it was actually my first time using normal mapping, and I realized yesterday that it wasn't quite working properly. And I spent a long time trying to get it to work, but annoyingly it just wasn't happening. So I'm very sorry about that. Unfortunately, all I could prepare in the remaining time was a short tutorial on cel shading, but I can assure you that next time we will be doing normal maps. The time after that we'll be doing font rendering, and then after that we'll do particle effects, and then we will cover shadows. And if there are any other graphical topics that you'd like me to cover, then do let me know. Before we start, I should just point out that there were actually 8 other OpenGL tutorials between episode 29 and this episode, but because they were all about rendering water, I put them all in their own mini-series. If you haven't done them and you don't want to do them, then that shouldn't be too much of a problem, but just be aware that there might be a few minor differences in the code since episode 29. I think the main one being that we created a method in the master renderer that does all the processing of entities and terrains and sends them off to be rendered, instead of having all of this in the main game loop. So let's get started with cel shading. Instead of the usual smooth gradient of shading that we have in our engine, cel shading creates these very definite levels of shading on the objects. Usually when a part of an object goes from being in the shade to being in the light, the brightness of the surface changes smoothly, so in graph form it would look something like this, with the brightness value gradually changing as the surface becomes more and more lit up by the light. With cel shading, we have a certain number of brightness levels, and the brightness of the surface has to be one of these values. Here I've used 4 levels, but you can choose to use as many levels as you like. The way it works is to find out which level of brightness each point on the surface is, and then to cap the brightness of that point to the lower brightness limit of that level. Take this top level here for example. Every point with a brightness of between these two values, so that's this part of the line, gets set to the lower limit of this level. The same happens for the next level as well, so any point with a brightness between these two limits gets set to the lower limit value, and the same for the other levels. So instead of the continuous smooth line, we instead get these very discrete levels of brightness. And it's very easy to implement this in the Fragment shader. First we have to decide how many levels we want to use, so I'm going to choose to use 3 levels of shading here. Then down here we need to find the brightness value, which is the value that we're going to be capping, and if you remember from the lighting tutorials, this is just a number between 1 and 0, which indicates how bright this fragment of the surface should be. The first thing we need to do is to find out which shading level this brightness value is in, and to do that we simply multiply it by the number of levels, and then we floor the result. To give you an example of this, imagine that we're dealing with a brightness value of 0.4 in our 4-level shading system. To find out which level it's in, we simply multiply it by the number of levels, which gives us 1.6, and then we floor the result, which tells us that this brightness value is in shading level 1. Once we've calculated the level of shading, we then just need to set the brightness to the lower limit of that level, and to get the lower limit of any given level, we simply divide the level by the total number of levels. And you should be able to see here how dividing the level number by the total number of levels would give you the lower limit of that shading level. So if we go and run that, you can see that the cel shading is already working on the entities. The effect works best on the more rounded objects and objects with rather simple textures, so you can see here that I'm just using solid colours for all of my textures. The only thing that could be improved here is that the specular lighting on the rocks is still very smooth and it doesn't really fit in with the cel shaded style. So let's go back into the Fragment shader and we're just going to do the exact same 2 lines, but this time we're going to be doing it for the damped factor variable in the specular lighting calculation. And once you've done that, you can run it again and it should look a lot better. You can of course do exactly the same thing in the terrain fragment shader to achieve a similar effect on the terrain, and for the skybox I've done a similar kind of thing, but I first calculated the brightness of the texture by averaging the RGB components of the colour, and then I've capped that brightness value using 10 shading levels, and I've used that to make the skybox all different shades of pink, or whatever colour the fog colour is set to. So that is it for this week. My apologies again for not being able to finish the normal mapping tutorial, but that will definitely be out in 2 weeks' time. But yeah, thank you guys very much for watching this video. Do subscribe if you haven't already. Have a fantastic week, and I will see you all next time.